Hello everyone, my name is SANJUSHREE and I'm from point R.NAGARAJAH. Today my group members and I are going to present Communication Principle Project, which is titled Pulse Code Modulation PCM. Introduction. Pulse code modulation PCM is a digital scheme to transmit analog data. When a signal is pulse code modulated, its analog information is converted into a binary sequence. At the source of transmitter of a communication circuit, an analog signal is sampled at regular time intervals to generate a PCM signal. The sampling rate is several times the analog signal's maximum frequency. PCM has advantages over other modulation methods in terms of noise resistance and digital processing. Once modulated in the communication channel, PCM is particularly resistant to noise. PCM can be processed entirely in the digital domain, allowing for any desired signal alterations that would otherwise be impossible in the analog domain.
Hello, my name is YONG and I'll be explaining the MATLAB coding and output for example 1. In the first part of this code, we shall define our analog signal as a sine signal. After that, we shall define our square signal, which is shown right here. After that, we shall define our sample signal, which is the product of our analog signal and square signal. In figure 1, we shall plot out both the analog signal and the sample signal. Here is our output for figure 1, which shows the analog signal and the sample signal. After this, we will encode our sample signal using the uEncode command. This encoded signal will then be decoded using the udecode command. Both the encoded signal and decoded signal will then be plotted out in figure 2. Here is our output for figure 2, which shows both the encoded and decoded signal. Finally, in figure 3, we shall plot out our square signal. Here is figure 3, which shows the square signal. In the assignment exercise, we are also asked, what is the frequency of the analog signal that has been used in example 1? As we can see from the code, the value of A is the analog signal. By comparing 2 pi ft to 2 pi t, we can confer that the value of f is equals to 1, which means that the frequency of the analog signal is also equals to 1.
Hello, my name is Tan Kai Xuan and I'm going to explain about example 2. In this example, we are given a message signal and we are required to produce received signals with and without compending. We are given the received signal, which is a cardinal sine function. We proceed to compress the signal using mu law, one way of quantizing. Then the signal is encoded, decoded, and finally expanded. We compare the output and input of the signal by plotting both signals in a single graph. Next, we repeat the process. However, we remove the compress and expand function to produce an output without compending. So these are the outputs. The red line is the original cardinal signal, while the black and green lines are the received signals using compending and received signals without compending. For question 2, we are required to generate a 2 kHz sinusoid with a peak-to-peak voltage of 2 volts and generate a quantized signal when n equals to 8 and n equals to 16 levels. Calculate signal to quantization noise ratio. So the first thing we do is to modify our code, increase the frequency to 2000. We also modify the time function so that we can see the graph clearly. We set the quantized level to every single encode and decode function and we run the program. So this is the received signal using and without using compending when the quantization level is 3 bits. When n equals to 16, that means it is 4 bits. So that we change this to 4 and then we run the program again. So this is the received signal with and without compending when it is 4 bits. The question also required us to calculate the signal to quantization noise ratio. So this is the formula to obtain the signal to quantization noise ratio with the unitless version and the one using dB. So by plugging in the numbers, we are using the 3 bits, so we are using 3. We can obtain that the signal to quantization noise ratio is 96. So if you want to change it to unit decibel, we use this formula. And by using the rules of logarithm, we can obtain this formula, and then we can calculate the signal to quantization noise ratio in dB, which is 19.82 dB. So when n equals to 16, which is 4 bits, we are able to obtain the signal to quantization noise ratio, which is 384, and with the unit decibel, which is 25.84 decibel.
Hello everyone, my name is SUMATHI. Here I'm going to show the simulation for example 1. In this example, we are required to produce sample and analog signal, encoded signal, decoded signal, and lastly square signal. For the diagram, we can find the components from library browser and search for the components here. So this is the diagram for sample and analog signal. This diagram will contain a signal generator, pulse generator, and a dot product, and lastly scope. Firstly, set the frequency to 1 and set the units to Hertz in signal generator. For the scope, we need to put two number of input. The first one we need to connect to the signal generator, and the second one connect to the dot product. Set the stop time to 3 as per question. So this is the output for sample and analog signal. As you can see here, this is the diagram for encoded signal. Here I added a uniform encoder, and number of input for this scope is 1. In uniform encoder, set the bits to 3. So this is the output for encoded signal. Next, this is the diagram for decoded signal. Here I added the uniform decoder and connect to the scope. In the uniform decoder, set the bits to 3. And this is the output for the decoded signal. From the output we get, we can see the difference between encoded and decoded signal in frequencies. Lastly, here I added a new scope which connects to the pulse generator. This is the output for the diagram, which is a square signal.
Hi, Assalamualaikum. My name is Amiza binti Amil, and I'm going to show you how to construct a connection in Simulink for exercise 2. This is the overall connection for compending and without compending receive signal. For the first part here, which is for the without compending receive signal, we need clock block, gain block, divide block, and signal generator. We set the amplitude into 1 and frequency into 2 pi. And then uniform encoder and uniform decoder, both bits are set into 3. And then we put scope in between the block to see the changes in the signal. As for the second part here, which is for the compending receive signal, we add 2 more blocks, which is MU low compressor and MU low expander. Both MU value are set into 255 and the peak signal magnitude are set into 1. We have to set the time into 3 and we can run the simulation. These are the original signal without undergo anything. And this are the signal after undergo the divide blocks. Okay, this are the signal after undergo the uniform encoder. The signal becomes square. Okay, this is the final output for without compending receive signal for 3 bits. And this is the final output for compending receive signal for 3 bits. And after that, we can change the value of bit for uniform encoder and decoder into 4 bits. Change the stop time into 4 and we can run the simulation. Okay, this is the final output for without companion receive signal for 4 bits. And this is the final output for companion receive signal for 4 bits.
Discussion. The PCM pulse code modulation can encode a message by converting them into binary bits. This is also known as source codes. Furthermore, PCM is noise resistant and can be processed digitally. Moreover, PCM can only be used in the digital domain and not in the analog domain. The AD converter converts continuous message signals into digital numbers. This means that each number represents quantized message signal level. Once the quantized signal is in the digital domain, signal processing will be much easier to generate by only applying the required mathematical equation. Aside from that, a DA converter does the opposite of what a AD converter does. It simply converts the digital numbers to analog voltages. Conclusion. In conclusion, we understood one of digital modulation technique. We also generate and plot the pulse code modulation PCM signal using MATLAB simulation. PCM is convenient for long distance communication because it has a higher transmitter efficiency and noise immunity, but it requires large bandwidth as compared to analog system. Moreover, the PCM encoding, decoding and quantizing circuit of PCM is extremely complex. That's all from us today. Thank you.